Good Monday afternoon to you. This is the December 23rd edition of the map discussion. We're looking at the 850 millibar map here, or just above the surface at approximately 1.5 kilometers up in the atmosphere. This map is really good at looking at low-level jets and cyclones and anticyclones, but here we have some enhanced flow at low-level jet. I don't know, maybe, but it's not very strong. But this is indicative of a upper-level frontal system. You can see the little kinks in the geopotential heights here, as well as the temperature. There's like a thermal ridge right along that front. And this enhanced flow is helping to bring in warmer air. And in previous videos, we mentioned how this week between Christmas and New Year's will be a little warmer than it has been over the past few days, at least, or a week or so. But as we go up in the atmosphere, this is 700 millibars. We're approximately 3 kilometers up now. This trough feature is still visible, and a little bit of a thermal ridge right out ahead of it. But this trough here at 700 millibars is helping to kind of strengthen a low-level surface, low pressure system that we'll see in a moment. But as we go up a little bit further, this trough feature is still there, with enhanced flow across the eastern Great Lakes. And if we go to this is 500 millibar level, this is about halfway, this is about 6 kilometers up. And if we go at the tippy top of the weather producing atmosphere, more or less, this is the 250 millibar heights. So we're approximately 11 kilometers up in the atmosphere at this point. This is a good map to look at the jet stream across the eastern part of the United States. Well, a vast majority of the 2/3 eastern. The jet stream is very weak, but we have some strengthening of the jet stream across the Pacific Northwest that we'll get into momentarily. The next map is the 500 millibar height change. And the height changes are good to indicate areas of synoptic scale lift. And when you have synoptic scale lift, you have height falls highlighted in blue. And that helps to increase the strength of surface and low pressure systems. And where you have height rises, this is strengthening high pressure systems. So over here in the New England, the weather is quite nice. It is clear. And over here in the Midwest, upper Mississippi River Valley, it should be cloudy because we have some synoptic scale lifts out ahead of this trough feature. So let's take a look at satellite. Yes, indeed, we do have some clouds across the mid-Mississippi River Valley. This is in regards to that synoptic scale lift across this area. We also have a very weak, elongated almost surface cyclone. We have a couple of them. We have one in northern Canada, one in the upper Mississippi River Valley, and the other one in the panhandle of Texas, perhaps eastern New Mexico, that is being analyzed by our friends at the College of DuPage. And overlaid is radar and a satellite, visible satellite like you would see from space. And if we kind of go through time here, this is the latest. This low pressure center is very, very weak, which if you remember from the height falls weren't all that impressive either. So kind of coincides. So it's along this frontal boundary. This low pressure down here in the panhandle of Texas will help spread clouds and rain across the mid-south and the southern Mississippi River valleys through the day on Christmas Eve. So let's take a look at the forecast. So let's take a look at the Ensemble Prediction System's mean 2-meter temperature anomaly averaged over the next 5 days. Again, remember, this gives us a good indication of the type of air masses and where they're located. And the first thing that you can see is very, very warm temperatures across the vast majority of the lower 48 in Canada, exception being New England and extending into the Carolinas. That cold high pressure system that we've been talking about has verified. And what's next is a rebound in temperatures, so to speak. That frontal system is going to help bring in some very moist and very warm air just in time for Christmas and the week after. As we get closer to the New Year's and just after New Year's, you'll see this very warm air mass be pushed out of the way, and replacing it is a cold air mass. And if you remember, when cold replaces warm, fireworks go off. So let's look at the fireworks. So whenever you're looking at a fireworks show, you have to muddle through traffic and, well, the pre-show, before the grand finale. The pre-show looks like this. There's that high pressure system across the eastern United States. Here's our weak low pressure center in the northern Mississippi River Valley, and our weak low pressure system over the southern plains, the panhandle of Texas. Now, if we push through this, you'll notice that the snow gets pushed to the eastern Great Lakes, and a little bit of a lake effect snow machine. Those lakes have probably cooled off and just enough to where the lake effect snow machine isn't as big as it is, but it's still gonna dump some snow. The next thing that you'll see is probably the system off the coast of the Carolinas. We looked at this maybe a few videos ago, a couple of videos ago last week, and how this low pressure system was wanting to, the models were wanting to push some precipitation further through the Charlotte metro region. The models have been going back and forth over the last few days, but it looks like the majority of the models have the precipitation along and east of I-95 for the most part. What's interesting is the temperatures in this area will be close to freezing. So places like Raleigh might have a brief onset of freezing rain, perhaps. Nothing too major. Not a lot of accumulation is expected, but it's at least possible Tuesday morning, and not lasting all that long either, as this system is fairly progressive, and by Tuesday afternoon is well out of the Raleigh-Durham area and mainly affecting the coastal regions as rain. Then your attention might also turn to that system across the southern plains that's bringing in some rain and perhaps some thunderstorms on Christmas Eve, like places like Tyler, Texas, up through Little Rock, Arkansas, and St. Louis. Could be seen places like rain, as well as parts of southern and east central Texas, and mainly the fringes of the Carolina coast, like Cape Hatteras, Kill Devil Hills, southward through New Bern, perhaps getting into Wilmington and places south of Myrtle Beach, but that's pretty much a nuisance than anything. This system kind of weakens as it moves eastward, and it kind of fizzles out, and high pressure regains control of the eastern seaboard. And then this transition from the warmer air into the colder air is going to take place over a series of storms. This one is not it. So this one is going to be fairly weak, and mainly going to the north, into the upper Mississippi River Valley. But along that front, or along that upper level disturbance, is going to be some showers and perhaps thunderstorms. Now notice that it's going to be all rain, even up through southern Canada. So yeah, it's going to be pretty warm. And this is Saturday, December 28th, or Friday, December 27th, late in the evening, 10 p.m. Eastern time, Friday, December 27th. We push this on a little bit further, and that here's one of those systems that helps bring in the cooler air. Doesn't look like much. It's not going to start out as much, but the fireworks are coming, the grand finale. Along this frontal system, some showers, perhaps thunderstorms, high pressures is in control. And this, we're getting into the later parts of the weekend. This is 10 a.m. Sunday, December 29th. We have an approaching frontal boundary across the southern Appalachians with some rain out ahead of it. And it's going to be rain because it's warm. Which by Sunday afternoon, December 29th, in late evening, expect some perhaps pretty hefty precipitation across the western Carolinas and Georgia, and even northward up through West Virginia. But this is one of those storms that's going to initiate the cold air events. The next one, the bigger one, is going to be this one. And notice that unlike its predecessor, there's snow on the back side of this across parts of northern South Dakota and southern half of North Dakota, and rain south of that. So remember, in this map, the 5,400 meter thickness, which is traditionally the rain snow line, is highlighted in purple in this map, thanks to those working very hard at the College of DuPage. Allows us to see that very clearly. And notice that this thing wraps up, and there's going to be rain that's going to be changing over to snow, and perhaps even blizzard type conditions across parts of Minnesota, South and North Dakota, and even getting into northwestern Iowa. That's one of the storms that's going to help bring in some pretty cool air. The grand finale, getting into the New Year's, is going to be this joker here. Now we are 246 hours out. This is 7 a.m. January 2nd, 7 a.m. Eastern. This is one of those springtime storms where you have rain and perhaps thunderstorms on the front side of it and snow on the back side of it, and between this purple area is ice. Not good conditions in any place where this storm is affecting, but it's interesting. Now, the thing about the GFS is when you're this far out, there is a cold bias. There tends to be a cold bias in the GFS. So, while this says snow as far south as the Panhandle, maybe perhaps even Amarillo, Texas, is it? It's 246 hours out. We're almost out there in La La Land. But here's another interesting aspect of this solution. You have low pressure to the south, directly to the south of high pressure. And if we have a progressive pattern, as is depicted in some of the other models, these two features will pretty much slide east together. The other interesting aspect of this type of solution is in the climate indices. So let's look at those. So here is the observation and the GEFS forecast for the North Atlantic Oscillation. Now, the positive phase, where this index is positive, you have lower pressure over southern Greenland. And it almost acts like a magnet for surface cyclones. So storms tend to go towards that low pressure system, or that low pressure anomaly, I'll say. When it's in its negative phase, storms tend to take a more southerly track. And here in the red and the dotted dashed black line are the forecasts. The mean forecast in this dotted black line is, or dashed black line, is the negative mean NAO phase. So what this means is if the NAO is negative, then the eastern parts of the United States is opened up to cold air outbreaks. It's weak. The mean forecast is weak, but there we are. And look at the date. It is after the new year. And that storm was, well, we can look at it here, after the new year. So, the other piece of the puzzle is the PNA, the Pacific North American Oscillation. Now, in its positive phase, there tends to be high pressure over the maybe southern or southwestern part of Canada, northwestern part of the United States, Pacific Northwest, somewhere just off the coast. There tends to be high pressure, anomalously high pressure. And when there's anomalously high pressure, on the eastern side of the high pressure is northerly flow. So when you have negative NAO, negative North Atlantic Oscillation, which brings a more southerly storm track across the south, and northerly flow enhanced by the PNA's positive phase, this gives clues that the transition will be underway after the first of the year. Now, this is a lot of information. It is very much far in advance. And right now, the mean forecast is for both of these indices to be fairly weak in its in their respective phases. Positive for the PNA, negative for the North Atlantic. So when they're weak like that, which one wins out? Who knows? And it might not be much of anything, but it's interesting to note that the stage looks like it's being set for the potential for some wintry weather across the eastern parts of the United States. Now, the other caveat is, sure, we'll have cold air outbreaks. If these forecasts validate themselves, we will have some cold air outbreaks. But notice that none of these precipitations was mentioned. None of the precipitation stuff was mentioned. So all we're saying is temperatures right now. The implication is that when you have negative North Atlantic phase and positive Pacific North American phase, is snowstorms could be a possibility somewhere along the eastern seaboard or even interior, such as Indiana. But that's not exactly what that means. It's a possibility because you would need, we might have the cold air, but you would also need precipitation. You need enough moisture. And when you have cold air and moisture, that's when you can have the potential for a winter storm. But those have to meet up at the same time, and it's the timing that's the key here. Is the moisture and the cold air going to be in the same place at the same time? That is the aspect of the forecast that is highly uncertain. But what is certain right now is that the pieces are on the table. The pieces are on the table for a pretty good winter storm sometime after the new year. If these models validate, if they verify, then yeah. But you also have to keep in mind that the GFS has a cold bias. So that'll do it for this video. We'll keep you updated with the forecast and how the models change, because they will change. It's inevitable. But thank you for watching, and I will see you in the next one.